Hi Eagles! Today we are going to be doing our guided practice for 14.5. Today you're going to need three different things. One, you're going to need a pencil, you're going to need your notebook paper, and then you're also going to need, if you can, a piece of the centimeter grid paper that I assigned through your Pearson assignments, because we are going to try to draw a shape with a certain area today. All right, now hopefully you guys have already watched the video. Today we're working on finding area using distributive property. And we learned about that when we first learned about multiplication. Remember, sometimes it's easier if there's really big numbers or numbers that we're not that good with to draw a line through an array and distribute the numbers to figure out your total. Now, if you've noticed, I think some of you probably have, finding area is a lot like drawing an array. When you have a square and you have a square area inside, square units, it's the same thing as an array. So today we're going to be working on finding the area of a shape using distributive property. So for 14.5, your learning target is I can use distributive property to find the area of a rectangle. And remember, you can pause me at any time if you need to. Oh, and you guys should have noticed I wrote down my formula because I don't want to forget that. And today we're going to be using that quite a bit. So for those of you that want to follow along, today we are on page 338. And like I said, sometimes it's easier to distribute or make into smaller rectangles and then add them all up together. Now, as I've been teaching you how to find area, there's two important things. One, I've noticed on your quick checks, some of you do have the right answer. However, you have the right numerical answer, but you're not having the correct unit. Area is always measured in square units. So please make sure that you always choose that unit. Now here, I've also taught you that you always go length times width. However, we know because of commutative property, you can multiply in either way and you'll get the same answer. So today we're actually going to be going up and down, so width times the length. All right, here we go with number one of our guided practice. Copy and complete the equation that represents the picture. So I'm going to write down the numbers that you see there. So number one, 6 times, I'm going to draw a line for the blank so I don't forget that it's blank, equals 6 times, and then parentheses, 2 plus blank, equals blank times 2 plus 6 times blank. Now, I know this looks kind of difficult, but please do not worry. This is really not a hard lesson if you just follow along and use what we have learned so far this year. So my problem looks like that right now. Now, what we need to do is figure out all of the blanks. So the first thing we're going to find out is what is the total for each of these in the original area equals length times width. So if it's 6 times what is going up and down. So let's check out our drawing, and I might zoom in on it just a little bit more so that we can really get a clear picture. All right, now we know that the first one is 6. So 1, 2, 3, 4, 5. So that is not the one, that's not the 6. So let's find 6. 1, 2, 3, 4, 5, 6. So the one thing is that this one here will never ever change. So now we are distributing the 5. So 6 up and down times 2 plus what makes 5? Okay, good. So it's 6 times 5 equals 6 times 2 plus 3. Because if this is a 5 right here, 5, 2 plus 3, the numbers in these parentheses have to equal this row right there. Now, I know this seems kind of difficult, but don't you worry, you'll get it. Now, The one thing that you have to remember is up and down is not going to change. And really what they've done, if you notice, they've drawn these squares right here so that we can actually just see. So we now need to put in parentheses 6 times 2 and 6 times 3. Now we have to figure out what the total for each of the parentheses is. Sorry, I keep moving that. So 6 times 2 is 12 plus 6 times 3, 6, 12, 18 is 18. And 12 plus 18 is 30 square units. Now remember, if you don't write down square, you will get the answer wrong. So my paper looks like this, and really what you then need to figure out is the original rectangle, 6 times 5, does that equal 30? Yes, it does. This does look a little bit cumbersome, but don't worry, sometimes it will help us out. Sometimes, like in my kitchen, I had to figure this out when we were doing the irregular shape because I couldn't just go length times width because there were different shapes within that. All right, here we go on to number 2. Don't worry, we will do enough that you will get this. Draw a picture on grid paper. Oops, upside down for you again. To show, okay, so here's my grid paper. Now, it says 7 times 6. So first I'm going to draw a 7 down and a 6 across. So maybe I'll use a green one. I don't know if this highlighter will work very well. I really want you guys to be able to see this. So 7 down, 1, 2, 3, 7, and 6 across. And then I'm going to make it a rectangle, closing up my shape. Wow, it is really windy. Can you guys hear that wind behind me? Crazy. You know what? I'm going to trace over it really fast in red because I don't think you guys are going to be able to see that on this computer screen. This is way more fun in person because then we get to use a variety of markers, coloring supplies. Sorry that we're doing it this way. All right, now we're going to distribute. I don't necessarily use this one in the middle that much, but I'm going to use this one right here because I know that we're going to distribute out this 6 and I'm going to draw a line so I have 2 separate rectangles that are 7 times 3 and 7 times 3. So I know that it's 7 up and down, so I'm going to go 1, 2, 3 and draw my line right there. Now, on my paper, so let me go ahead and show you what that looks like. This is what my rectangle looks like. So I had one big rectangle. It was 7 times 6. And now I have 2 separate rectangles that are 7 times 3 and 7 times 3. So what I'm going to do now is write on number 2 on my paper, and I'm going to write 7 times 6 equals 7 times 3 plus 7 times 3. So my paper looks like this. So now I'm just going to make sure that I have the same answers on both sides. Because remember, an equation has to have the same amount on both sides of the equal sign to be true. Okay, so I know that 7 times 3, 7, 14, 21 is 21 plus 21 equals 42 square units. Now I'm just going to check to make sure. What is 7 times 6? Yep, 7 times 6 is 42. So this is the correct answer. Now, if you were not sure about that, another way to do it would be, oops, I keep moving this the wrong direction today. I'm so sorry. Another way to do it would be to count all the squares up in the middle. But we're trying to get away from that because sometimes that can just take forever. All right, number 3. We have to think a little bit on number 3, where we talked about the importance of thinking. Okay. Describe a way to separate a 5 by 6 rectangle into 2 smaller rectangles. Okay, I'm going to actually draw this on my grid paper. A 5 by 6. Oops, 1, 2, 3, 4, 5, 6. miscounted a little bit there. Okay, so now if I have this rectangle right here that is 5 by 6, how can I divide this, oh, this one, into two smaller rectangles? That's right, I could draw a line right down the middle and have it be 5 times 3 plus 5 times 3. What if I wanted to have it be, I'm going to write that down. I could say 5 times 3 plus 5 times 3. And the whole thing is a 5 times 6. What if I went and drew a line right here? I'm going to draw this one in green so you guys can see a little bit of a difference. What would happen if I split my rectangle right there? What would be in the parentheses now? That's right, 5 times 2 and 5 times 4, because 5 times 2 and 5 times 4, because 2 plus 4 equals 6. Now, one thing that I want you guys to really notice, and I didn't bring this up until now, is one of the numbers never ever changes. For instance, it's 5 times 6, then you have 5 right here and 5 right there, because going up and down this row, the rows never ever change for distributive property. Here again, you have 5 and 5 and 5. So depending on which way you go, up and down or side to side, one of those numbers never ever changes. And don't forget, it is always square units. Just because this can be kind of a challenge, let's do one more together. Let's go ahead and do number 4, because like I said, it's really not as hard as it looks. So number 4. Okay, I'm going to write down the equation. So if I look at this whole rectangle, the entire thing is 1, I'll use my cursor so you can see, 1, 2, 3, 4, 5. See how it's kind of an array? 5 times, and let's count all the way across. 1, 2, 3, 4, 5, 6, 7. Okay, so the entire array is 5 times 7. Now we're going to distribute that, and the book has told us that what will never ever change is the first number. So it's going to be 5 times parentheses. So now we have to figure out what numbers with where they split it equal the total. So we have 4, and 4 plus what is 7. Because we have a picture, it makes it a little bit easier. 1, 2, 3, 4 plus 1, 2, 3. Okay, now we're going to keep going. We're going to now distribute and write parentheses for each rectangle. So remember, one of the numbers never changes, so that's going to be this one going up and down because we didn't split it side to side. We split it up and down, so the rows don't change. So it's 1, 2, 3, 4, 5. So I'm actually going to write a 5 for this one here and this one here times, okay, now we know that this is 1, 2, 3, 4 times 4 plus 5 times, and that's right, we already figured it out, 3. And your equation should look like this. It's kind of long. So really, all we have to do is figure out this parentheses and this set of parentheses and then add them together. So 5 times 4 is 20, and 5 times 3 is 15. So 20 plus 15 is 35 square units. And that is the answer. And then we can think about it and go back and say, well, wait a minute, what is 5 times 7? Now, sometimes it's easier just to figure it out the first time and say, I know what 5 times 7 is. But for the lesson today, I do want you to try using distributive property, since 1, that's the learning target, and 2, it will come in a couple more lessons. We'll be doing it much, much more. Okay? So please, as you go, go ahead and I would do 5 and then look at this, write an equation. See if you can write one without any numbers.